that. All right, so we're talking about conditions for parallelograms, conditions for parallelograms. Okay, if you go to page 410, we are on page 410. Okay, there's a girl who is doing some bird watching there. And you can see that she has a mount that mounts her binoculars there. And you can see that there's a parallelogram there, okay? All right, there's a parallelogram there, okay? So we're talking about the 5 conditions that result in a parallelogram, all right? So if you look at the theorem there, you have 6.3-1, 2, and 3 first. Let's look at that. 6.3-1, we got if one pair of opposite sides of a quadrilateral are parallel, then it's incongruent, then it's a parallelogram. So in other words, if you have a quadrilateral where the one side is parallel and that same side is congruent, okay? So if they're parallel and they're congruent, then this is a parallelogram, okay? So if you want to take a good look at the things that's in the parentheses there, it says quadrilateral with pair of opposite sides parallel and congruent, okay? You should be able to read that by now what it's saying, right? That's the first one. The second one is if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. So basically, if this is congruent to this guy, this is congruent to this guy, then it's a parallelogram. So that's the second one. That's the second condition. Third one is if both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. Okay, so what that means is that if you have this guy and this guy being congruent, this guy and this guy being congruent, then it's a parallelogram, okay? So again, recap. Our first condition was that the opposite sides are parallel and congruent. Second one was both sets of opposite sides are congruent. The third one were that both sets of opposite angles were congruent, okay? Then it's a parallelogram, okay? Let's go to the fourth one. The fourth one is on page 411. If an angle of a quadrilateral is supplementary to both of its consecutive angles, so if I have this angle here and it is supplementary to this guy and this guy, all right, then it's a parallelogram, okay? So the fifth one is that if the diagonals bisect each other, then it's a parallelogram, okay? And then it is on that one, the very last one is saying that if this guy and this guy are the same and this guy and this guy are the same, in other words, if the diagonals bisect each other, then it is a parallelogram, okay? So again, we have 5 of them, right? We have 5 separate conditions, okay? All right. So let's do example number 1. Okay, so somebody just logged in as user. Who is user? Who is this?
Oh, this is Daniel. I just couldn't figure out how to fix my name.
Okay, that sounds good. Just checking them. So I want to make sure it's not somebody who we don't know. All right. So Daniel joined us a little late. Okay. All right. So example number 1. Verifying the figures are parallelograms. A, show that ABCD is a parallelogram for x is equal to 7, y is equal to 4. x is equal to 7 and y is equal to 4. And we have x plus 14, and then we have 3x, 2y plus 8, and we have 5y minus 4. So let's go ahead and put our x's and y's in and see what we get. X is equal to 7, so if I do this, I'm going to get 7 plus 14, 21. This is going to be 3 times 7, 21. Y is equal to 4, so I go here, I get 2 times 4 plus 8. 8 plus 8 is 16. Over here, I'm going to get 20 minus 4, which is equal to 16. So as you can see, these two sides are congruent, and these two sides are congruent. Therefore, it's a parallelogram. Can anybody tell me which condition that is? Is it 6.3-1, 6.3-5? Which one is it there?
6.3-2.
Is it -2? Yes, it is, right? Quadrilateral with opposite sides being parallel. Very good, right? What? Opposite sides being congruent is a parallelogram, right? That's 6.3-2. Good work. All right, so that's A. Now let's look at B. If we look at B, we have show that it's a parallelogram for Z is equal to 11. W is equal to 4.5. And we're going to have angles of 9Z plus 19. And over here, we're going to have 11Z minus 3. Over here, we're going to have 14W minus 1. Over here, we do not have 1. Okay, so 9Z plus 19. So let's do that one first. 9Z, which is 9 times 11, plus 19 is 118. Then over here, I'm going to get 11 times 11 minus 3, 121 minus 3, 118. Okay, over here, I'm going to have 14 times 4.5 minus 1. So if I do that, I get 62. 62. Okay. So from this angle standpoint, you can see that the consecutive angles, this guy and this guy, is going to add to 180, so they're supplementary. And if you add these two guys, I have 62 plus 118. Again, it's supplementary. So you have consecutive angles to one angle being supplementary. And that is condition what? What condition was that one? 6.3 dash what?
4.
4. 6.3-4. Good. Okay, so let's flip the page. Go to example number 2. So we have example number 2. A, determine if each quadrilateral must be a parallelogram. Justify your answer. And on A, we have a situation where this guy is parallel and this guy is congruent. Okay? Is that one of the conditions? I don't think so, right? There is no condition that looks like this, right? In other words, I can have a situation where if I drew something like that, where this guy and this guy is congruent, that's definitely not a parallelogram, right? Okay, all right, so obviously that does not work. B, we have a situation where the diagonals of the quadrilateral are being bisected. So is this a parallelogram? And if so, what condition is this?
Yes, and it's 6-3-5.
6-3-5, good work. 6-3-5 says that if the diagonals are bisected, the quadrilateral is a parallelogram. Okay. Then we have example number 3. Example number 3, show that quadrilateral ABCD is a parallelogram by using the given definition or theorem. So let's do A first. We have B is -2 and 7. So that's B. We're doing A here. That's B. And we have A, which is -3 and 2, -3 and 2. This is A, -3 and 2. And then we have down here, like that. And we have C here, C, and we have D. C is 2 and 4. And then we have D, which is 1 and -1. We rewrite that. D is 1 and -1. Okay, so what we're going to do is we're going to prove that this is parallel and this is parallel. And we're going to do that by looking at the slopes. Okay, so let's compare the slopes of BC and AD. So BC and AD. Okay, the slope for BC is this guy and this guy. So I'm going to do y2 minus y1 over x2 minus x1. If I do that, I get -3 on top, and over here, I'm going to get 4. Let's do AD now. AD, this is y2 minus y1 over x2 minus x1. Over I get -3 on top. The bottom I get 4. So indeed, BC and AD are parallel. So I proved that. So let's compare AB and DC. So AB, the slope of AB is going to be from here to here. So I'm going to go y2 minus y1 over x2 minus x1. By the way, it doesn't really matter which one I choose for to be x1, y1, and x2, y2, right? As long as I keep them straight, it doesn't really matter. So I'm going to get 5, -2 plus 3, so you get +1. And then DC is here to here. So if I do this as y2 minus y1, over here you get x2 minus x1. 4 minus 1 is 5. 2 minus 1 is 1. And indeed, they are both 5. So AB is parallel to DC. And therefore, this is a parallelogram, right? It's a parallelogram. Okay? All right. So I was a little bit drawn out. Okay, you just had to do the same slope equation 4 separate times and compare them to make sure that they are parallel. Okay? All right. So that's that. That's A. Now let's see if we can do B. And for B, we have, again, we're given 4 points. And it's going to look like this. This is F. F is -4, -2. Then we're going to have G, which is -2 and 2. So we're going to go like that. And then we're going to go up slightly over here to get H. H was 4 and 3. And we're going to go up like that. Like that. H, this must be what? J. This is J. J is 2 and -1. And the question states, find the slopes and lengths of one pair of opposite sides, okay? So let's compare, let's do these two here. So let's do the slopes. So slope, we're going to compare the slope of GH and FJ. GH, so GH, so Y2 minus Y1, X2 minus X1, 1/7. And over here, I'm going to get -1Y2 minus Y1. And we're going to get 2 minus 4. Okay, what happened here? Oh, this was a 2. Make it 1/6. -1 plus 2 is 1. And over here we have 2 plus 4, which is 6. They're the same 1/6. So indeed, GH and FJ are parallel. Now let's go ahead and compare the lengths. Okay, so we have to do the distance formula from here to here. So GH is going to be equal to Y2 minus Y1. We'll do the X1. You guys learned the X2 minus X1, so let's do it that way. X2 minus X1. I'm going to square this plus Y2 minus Y1 squared. If I do that, I'm going to get square root of this is 6 squared plus 1 squared, square root of 37. Now let's look at FJ. FJ is X2 minus X1 squared plus Y2 minus Y1 squared. 2 minus 4 is 6, so that's going to be the same 6 squared. Over here, I'm going to have -1 minus 2. So it's going to be 1 squared, and indeed, they are both the square root of 37. So they are the same length, so they're congruent in length, and they are parallel to each other. So this has to be a parallelogram. Okay? Example number 4, in the parallelogram mount that we looked at initially, where the bird watcher had mounted her binoculars. Okay. That's example number 4. So we're doing example number 4 here. Okay, in the parallelogram mount, there are bolts at P, Q, R, and S, such that PQ and RS and QR and SP are the same. The frame moves when you raise and lower the binoculars. Why is PQRS always a parallelogram? So which condition always stays the same, no matter how you change the setting there? Because they're hinged, right? RS and PQ are always going to be the same. QR and SP are always going to be the same, right? So which condition is this for the parallelogram? Is it 6.3 dash? Which one is it? Holden, which one is it?
Six dash 3-1.
I don't think that's it, is it? No, try again. Thanks for playing. Kayla, which one?
I'm sorry. That was cutting in and out. Could you repeat that again?
So example number 4. Why is that a parallelogram? Which condition is it?
Both pairs of the opposite sides of the quadrilateral are congruent.
Which one is it? Carter, which condition is it? Which one is it?
Six dash 3-2.
Correct. 6-3-2. That is correct. That is the winner. Okay, so we're done with this. Let me go ahead and give you your homework on 6.36/3. Your homework. And I do not have this prepared. How can that be? Was this it? I have something here. Let me make sure this is the correct one. We're on page 414. Okay, we're correct. So it is 9 through 13 and 17 through 23, okay?